Om Sri Sai Ram. My humble salutations to my beloved Bhagwan, respected elders, and my dear students. Hearty welcome to the linear algebra class. Today we are going to do some more problems on inner product vector space. Let V of C be the vector space of all continuous complex valued functions on the closed interval 0, 1. And for f comma g belongs to V, define inner product f comma g equal to integral 0 to 1 f of t into g of t conjugate dt. Then show that V is an inner product vector space. So given that f is a continuous complex valued function on 0, 1, therefore f of t is a complex number for every t belongs to closed interval 0, 1. Now take a and b to be in two complex numbers, f, g, h belongs to b for all, and t is any real number on the closed interval 0, 1. Now consider g comma f conjugates, that is nothing but integral 0 to 1 g of t into f of t whole conjugate dt. That is nothing but integral 0 to 1 g of t into f of t conjugate whole conjugate dt. That is equal to integral 0 to 1 g of t conjugate into f of t double conjugate dt. That is equal to integral 0 to 1 g of t conjugate into f of t dt. So that is equal to integral 0 to 1 f of t into g of t conjugate dt. That is nothing but inner product f comma g. Therefore inner product f comma g is same as inner product g comma f whole conjugate. So conjugacy property is verified. Next, second one. Inner product f comma f equal to integral 0 to 1 f of t into f of t conjugate dt. That is nothing but integral 0 to 1 modulus of f of t whole square dt, which is positive always, because mod f of t is always positive, whole square is always positive. And further, if inner product f comma f equal to 0, that implies integral 0 to 1 modulus of f of t whole square dt equal to 0, that implies definitely the integrand equal to 0. F of t equal to 0, that implies f is a 0 valued function, complex valued function. I hope that is clear. Okay. Next, we are having second property we are going to verify, that is third one, af plus bg comma h. That is nothing but integral 0 to 1 a times f of t plus b times g of t times h of t whole conjugate dt. That is equal to integral 0 to 1 modulus of a times f of t into h of t conjugate plus b times g of t into h of t conjugate dt. That is nothing but a times integral 0 to 1 f of t into h of t whole conjugate dt plus b times integral 0 to 1 g of t into h of t conjugate dt. That is nothing but a times inner product f comma h plus b times inner product g comma h. Therefore, inner product f comma g, which is defined as above, is an inner product on V of C. Therefore, V of C is an inner product vector space. Next, problem number 34. In the vector space V2 of C, the set of all ordered pairs, the field of complex of the field of, on the field of complex numbers, over the field of complex numbers, if inner product of alpha beta is defined as 2x1 y1 conjugate plus x1 y2 conjugate plus x2 y1 conjugate plus x2 y2 conjugate for all alpha equal to x1 x2 and beta equal to y1 y2 belongs to V2. Then prove that V2 of C is an inner product vector space. Now for that, once again take two complex numbers a and b, and alpha, beta, gamma belongs to ordered pairs of vectors in the V2 of C. Take a to be alpha to be equal to x1 x2 and beta equal to y1 y2, gamma equal to z1 z2, where x, y, z they belong to C. I hope that is clear. Next. So now we are going to verify what is beta alpha whole conjugate. That is nothing but 2 y1 x1 conjugate plus y1 x2 conjugate plus y2 x1 conjugate plus y2 x2 conjugate whole conjugate. That can be written as 2 times of y1 conjugate. X1 double conjugate means that becomes x1, and further this becomes y1 conjugate. Okay, this is y1 conjugate, x2 double conjugate becomes x2, y2 conjugate, x1 double conjugate means x1 plus y2 conjugate x2. Okay. Next, that is nothing but 2. Once again, they are all complex numbers. So we can write that as x1 y1 conjugate plus x1 y2 bar plus x2 y1 bar plus x2 y2 bar. That is nothing but the inner product alpha beta. Now inner product alpha alpha equal to 2x1 x1 conjugate plus x1 x2 conjugate plus x2 x1 conjugate plus x2 x2 conjugate. So that is nothing but, so I am going to split this as sum of two numbers, this one, 2 times. So that I am going to write it as twice, x1 x1 conjugate plus x1 x1 conjugate. Okay. Similarly, these 3 I am going to write again these 3 as the remaining 3. That is same, I have not changed. Okay, so these 2 I have taken that. I hope that is clear. x1 x2 conjugate plus x2 x1 conjugate plus x2 x2 conjugate. Now what is going to happen? x1 x1 conjugate is nothing but x1 square plus again from the second and third terms we can write that as, if we take x1 common, that becomes x1 conjugate plus x2 conjugate. Similarly, from these two, x2 if we take common, that becomes x1 conjugate plus x2 conjugate. So mod x1 square plus x1 x2 times x1 conjugate plus x2 conjugate. So once again, this can be written as, that is nothing but x1 plus x2 conjugate, whole conjugate. So once again, z bar. What is z bar? Mod z whole square. Similarly here, what is going to happen? This is mod x1 square plus x1 plus x2 whole square. That is always positive because square of a number is always positive. So now further, if the inner product alpha alpha equal to 0, that implies mod x1 square plus x1 plus x2 whole square equal to 0. That implies x1 is 0 and x1 plus x2 equal to 0. Therefore, automatically x2 is 0. That means alpha equal to 0, 0. Therefore, it is a 0 ordered pair. Now consider A alpha plus B beta gamma gamma. That can be written as A times inner product alpha gamma plus B times inner product beta gamma gamma. So now take alpha equal to x1 x2, beta equal to y1 y2, gamma equal to z1 z2. Now A alpha plus B beta equal to A times, what is alpha? x1 x2 plus B times y1 y2. That can be written as a single ordered pair as ax1 plus by1 comma ax2 plus by2. Now A alpha plus B beta comma gamma equal to ax1 plus by1 comma ax2 plus by2. That is the first coordinate, comma first vector, and the second part is z1 comma z2 ordered pair. So once again, by the given function, దీన్ని ఎలా నిర్వచించారు? 1 1 1 2 2 1 2 2. So this is nothing but, so how it is defined? Actually this is defined it as, sorry, so here 2 is missing. Actually it is, this is nothing but 2 times ax1 plus by1 into z1 conjugate plus ax1 plus by1 times z2 conjugate plus ax2 plus by2 times z1 conjugate plus ax2 plus by2 times z2 conjugate. So this is nothing but once again 2 times ax1 z1 conjugate plus 2 times by1 z1 conjugate plus ax1 z2 conjugate plus by1 z2 conjugate. అలాగే ax2 z1 conjugate plus by2 z1 conjugate ax2 z2 conjugate plus by2 z2 conjugate. So this is nothing but A times x1 z1 conjugate plus x1 z conjugate, x2 z1 conjugate plus x1 z2 conjugate plus B into, take B common, this becomes y1 comma z1 conjugate plus y2 times, here also you get actually 2 times, ఇక్కడ 2 times. Okay, so that is nothing but 2 is missing. Okay, so inner product A alpha plus B beta comma gamma is nothing but A times inner product alpha gamma plus B times inner product beta gamma. I hope that is clear. Now 34th problem. If inner product alpha beta equal to 0, that implies and implied by norm A alpha plus B beta whole square equal to modulus of A square into norm alpha square plus modulus of B into norm beta square. Now what is inner product alpha beta equal to 0 implies alpha is orthogonal to beta. Now inner product alpha beta whole conjugate equal to 0. Now norm A alpha plus B beta whole square can be written as A alpha plus B beta, A alpha plus B beta. So that is nothing but A alpha comma A alpha plus B beta. Okay. Similarly plus we can write that as another inner product B beta comma A alpha plus B beta. So once again that can be written as from A only A comes out. From the second part, if we take A, we get A conjugate. So A conjugate times inner product alpha alpha. Similarly, A come in times B conjugate. So this becomes A times B bar into inner product alpha beta. Okay. Again, similarly, we can write B beta. Okay. So how to write? So B this. So B into A conjugate inner product beta alpha plus B into B into B bar times inner product beta beta. So that is nothing but mod A square into norm alpha square plus AB bar into 0 because alpha and beta are orthogonal. Similarly BA bar into 0 plus mod B square into norm beta square. So finally, norm A alpha plus B beta whole square equal to modulus of A square into norm alpha square plus modulus of B square into norm beta square. So conversely, let norm A alpha plus B beta whole square is equal to mod A square norm alpha square plus modulus of B whole square into norm beta square. So A alpha plus B beta comma A alpha plus B beta equal to modulus A square into norm alpha square plus modulus of B square into norm beta square. So that now by the expansion, usual expansion, we get 4 terms A bar inner product alpha alpha, and here one, and then we have this and this. So totally 4 terms we will get A conjugate alpha alpha, A B bar times inner product alpha beta plus B A bar inner product beta alpha plus B B bar inner product beta beta. So that is equal to modulus of A square into norm alpha square plus mod B square into norm beta square. Now this is nothing but modulus of A whole square into norm alpha square plus AB bar into inner product alpha beta plus BA bar into inner product beta alpha plus mod B square into norm beta square, that is equal to modulus of A square into norm alpha square plus mod B square into norm beta square. Now 4 terms, 2 terms gets cancelled on both sides. So we get 2 terms only on the left hand side. AB bar times inner product alpha beta plus BA bar times inner product beta alpha equal to 0. Now that can be written as AB bar times inner product alpha beta plus AB conjugate whole conjugate times inner product alpha beta whole conjugate equal to 0. So this is nothing but if you take in this A equal to 1 and B equal to 1, inner product A conjugate becomes 1, B conjugate is also 1. Using this and 1, we get inner product alpha beta plus inner product alpha beta conjugate equal to 0. That is 2 times of real part of inner product alpha beta equal to 0. That means alpha beta la yokka vastava bhagamu 0 avutundi. I hope that is clear. Similarly, we are going to show that now suppose I take A to be I and B equal to 1, A bar becomes minus I, B bar becomes 1. So AB bar times inner product alpha beta plus BA bar times inner product alpha beta whole bar equal to 0 by 1. That can be written as I into 1 times inner product alpha beta plus 1 into minus I times inner product alpha beta whole conjugate equal to 0. Now what is happening? I, if we take common, inner product alpha beta minus inner product alpha beta whole conjugate equal to 0, but I is not equal to 0. So this is, now what is z minus z bar? X plus iy minus x minus iy. So x gets cancelled, you will get 2 by 2i by, that is nothing but 2 times of imaginary part of z. So imaginary of inner product alpha beta equal to 0. So that means what is that? How do you write z? X plus iy. What is x? Real part of z. Y is called imaginary part of z. So what is happening? Real part is also 0. Inner product of alpha beta is also 0. That means 0 plus I times 0 equal to 0. That means inner product alpha beta equal to 0. That implies alpha is orthogonal to beta. Now problem number 36. Norm u plus v whole square minus u minus v whole square plus I times norm u plus iv whole square minus I into norm u minus iv whole square equal to 4 times inner product to u comma v. Now norm u plus v whole square equal to u plus v comma u plus v. So once again we get u, uv, vu, vv. Okay, that is nothing but norm u square plus inner product uv plus inner product vu plus norm v square. Similarly, what is u minus v whole square? That is nothing but inner product u minus v, u minus v. So once again u minus v, minus vu minus into minus vv. That becomes norm u square. This is minus uv, this is minus vu, this is norm v square. Now u plus iv whole square. Norm u plus iv whole square is nothing but u plus iv into comma u plus iv. So once again what do you get here? Once again u comma u comma iv. Similarly iv comma u. Similarly iv comma iv. That is nothing but u plus I conjugate into uv plus I times vu plus I conjugate vv. So that is nothing but norm u square minus, what is I conjugate? Minus I. Minus I times inner product uv plus I times inner product vu plus norm v square. Because I conjugate, what is I conjugate? Minus I. That means minus I square. Minus I square means plus 1. That becomes norm v square. Next, therefore, now I times u plus iv whole square is nothing but I times norm u square plus I into minus I. That means plus 1 uv. Next, I into I square minus 1 times inner product vu plus I into norm v square. Call that as 3. Now, u minus iv whole square is nothing but u minus iv, u minus iv. So once again u minus I conjugate into uv minus I into vu minus into minus plus I square means minus 1 vv. That is nothing but norm u square plus I into we get this I into we get this. So multiply throughout by minus I, we get minus I times norm u square plus inner product uv minus inner product vu minus I into norm v square. I hope that is clear. Now we are going to add all this to get the required answer. So left hand side equal to norm u plus v whole square minus norm u minus v whole square plus I into norm u plus I v whole square minus I into norm u minus I. So combining all this, we can see that all are going to get cancelled. We get only 4 times inner product uv. That is the right hand side. Now state and prove triangle inequality. So what is a triangle inequality? Everybody knows. ఒక త్రిభుజంలో 2 భుజాల మీద మొత్తం ఎల్లప్పుడూ కూడా మూడవ భుజం యొక్క పొడవు కన్నా పెద్దది. Similarly here also, let V of f be an inner product vector space and alpha and beta are 2 vectors. Then norm alpha plus beta is always less than or equal to norm alpha plus norm beta. How to prove? Norm alpha plus beta whole square equal to inner product alpha beta comma alpha plus beta. So once again alpha plus inner product alpha beta plus inner product beta alpha plus inner product beta beta. That is norm alpha square plus norm alpha beta. Inner product alpha beta. Another one, inner product alpha beta whole conjugate plus norm beta square. Once again norm alpha square plus 2 into real part of inner product alpha beta plus norm beta square. So once again this is less than or equal to norm u square alpha square plus 2 times of inner product alpha beta plus norm beta square. So that can be done as by Cauchy squared inequality, norm alpha square plus 2 times of norm alpha square into norm beta plus norm beta square, that is equal to norm alpha plus norm beta whole square. So we have proved that norm alpha plus beta whole square is less than or equal to norm alpha plus norm beta. So norm alpha plus beta is always less than or equal to norm alpha plus norm beta. Now if norm alpha equal to AB and norm beta equal to AC, BC, then automatically the length of AC becomes norm alpha plus beta. And in a triangle we know that AB plus BC is always less than or equal to, is always greater than AC, or AC length will be less than AB plus BC. That is, norm alpha plus beta is always less than or equal to norm alpha plus norm beta. I hope that is clear. Now another one, V of 38th problem. V of f is an inner product vector space and alpha and beta are two vectors in V of f. Then modulus of norm alpha minus norm beta is always less than or equal to norm alpha minus beta. Now to prove this, consider norm alpha. Norm alpha can be written as norm alpha minus beta plus beta, that is less than or equal to norm alpha minus beta plus norm beta. So in other words, ఈ norm beta and left hand తీసుకొస్తే norm alpha minus norm beta is always less than or equal to norm alpha minus beta. Similarly, norm beta can be written as norm beta minus alpha plus alpha, that is always less than or equal to norm beta minus alpha plus norm alpha. So once again, norm beta minus norm alpha is less than or equal to norm beta minus alpha. Now taking minus common, we have minus of norm alpha minus norm beta is less than or equal to norm alpha minus beta, called the test 2. From 1 and 2, both the positive terms as well as the negative term are all, both are less than or equal to norm alpha minus beta. Therefore, modulus of inner product alpha minus modulus of norm alpha minus norm beta is always less than or equal to norm alpha minus beta. నెక్స్ట్ సమాంతర చతుర్భుజ నియమాన్ని ప్రవచించి నిరూపించండి. Parallelogram law. So let us say alpha and beta are two vectors in inner product vector space, then norm alpha plus beta whole square plus norm alpha minus beta whole square equal to 2 times norm alpha square plus 2 times norm beta square, or 2 times norm alpha square plus norm beta square. ఆల్ఫా బీటాలు ఆసన్న భుజాలుగా కలిగినటువంటి సమాంతర చతుర్భుజం తీసుకున్నప్పుడు వరుసగా వాటి యొక్క వికర్ణములు ఏసీ మరియు డీబీలు వరుసగా ఆల్ఫా ప్లస్ బీటా నామ్ ఆల్ఫా మైనస్ బీటా అన్నది ఏర్పడుతుంది. సో కర్ణాల మీద పొడవుల యొక్క వర్గాల మొత్తము ఎల్లప్పుడూ దేనికి సమానం అంటే వాటి ఆసన్న భుజాల యొక్క పొడవుల యొక్క వర్గాల మొత్తానికి రెట్టింపుగా ఉంటుంది అని చెప్తాం. So to prove this, consider norm alpha plus beta whole square plus norm alpha minus beta whole square. That is nothing but alpha plus beta comma alpha plus beta plus alpha minus beta inner product. Once again, alpha alpha plus inner product alpha beta plus inner product beta alpha plus inner product beta beta plus అదే విధంగా norm alpha inner product alpha alpha minus inner product alpha beta minus inner product beta alpha plus inner product beta beta. Now all of them, they get cancelled. That is nothing but 2 times inner product alpha alpha plus inner product beta beta. That is nothing but 2 times norm alpha square plus norm beta square. Therefore, AC whole square plus BD whole square equal to 2 times of AB square plus BC square. Another part. I hope that is clear to one and all. Now next, 40th problem. W is a subspace of a vector space, inner product vector space. Then W show that W perpendicular is a subspace of V of F. Now we are going to show that W perpendicular is a subspace of V of F. Now take two vectors alpha and beta belongs to W perpendicular. Therefore, inner product alpha comma small w equal to 0 and inner product beta comma w equal to 0 for all beta belongs to W. Now consider A alpha plus B beta comma W, that can be written as A times n product alpha W plus B times n product beta W. That is nothing but A times 0 plus B times 0, that is equal to 0. Therefore, A alpha plus B beta is orthogonal to W for all W in capital W. Therefore, A alpha plus B beta belongs to W perpendicular. Thus, for alpha, beta belongs to W perpendicular and AB belongs to F. A alpha plus B beta is also a member of W perpendicular. Therefore, W perpendicular is a subspace of V of F. Thank you very much for watching this video.